Okay, so this is meant to just go through a few examples of capacitors with you. So this first one says, what is the plate area? So we're looking for A of an air-filled 1 farad parallel plate capacitor. So that's our capital C, our capacitance. If the separation is 1 millimeter, so that's our distance. And it's air-filled, and so we know we're working with epsilon naught. So the equation for capacitance is equal to epsilon naught times area over distance. And that is, epsilon naught is 8.85 times 10 to the negative 12. I'm looking for my area over my distance of 1 millimeter, so 1 times 10 to the negative 3, and it's 1 farad. And this ends up being, like, if you go through and you do your calculation, I guess when I do my calculation I need to put the F. When you calculate out the area ends up coming out to be 113 square meters, and that's big. Like 113 square meters, that's like 10 meters by 10 meters squared. So when you get into class, I'm going to talk to you about, like, how is it that we get a such a big area in a little space. And it also kind of goes to show 1 farad is pretty big. Usually we work with microfarads or nanofarads. Okay, and then one more example of a capacitor with just some energy calculations. So this says 300 joules of energy is needed to shock a heart back into its normal rhythm. So remember we talked about in class how your heart is just a muscle and it's continually relying on these electrical impulses to cause it to be stimulated and basically beat. Okay, so we know that our energy of our capacitor needs to be 300 joules. And it says that the power supply to defibrillator is 5,000 volts. So that's my voltage difference. What is the capacitance required? So we're looking for C. And what is the charge? So we're looking for Q. So remember that we've got a few equations for capacitance for energy. 1/2 QV is 1. And then we also know that this could be 1/2 CV squared, or this could be 1/2 Q squared over C. So the first question just says, what is the capacitance required? We can use this equation here. In that we would say that my UC is equal to 1/2 CV squared. So 300. 300 is equal to 1/2 times C times my voltage squared. So 5,000 squared. Calculate out what that capacitance is. Again, I'm going to leave it blank, and when we get back in class, we can go over it. And then the second question is asking what the charge is. And for that one, we could use this first equation, 1/2 QV. So again, my energy is 300, 1/2 times Q times my 5,000. Calculate it out. Again, in class, we will go over the answer.